right, this is the fourth example for Hess's law. The only thing that's different about this particular example is that you're not clearly given the target equation. And when I say that, I mean that you don't have an equation written specifically that tells you that that is the target equation. Rather, they've given you a description of that target equation. And the description is this: the formation of 2 moles of nitrogen monoxide from its elements. That is the equation that they are describing. And nitrogen monoxide is NO, that is gas, and it says 2 moles of nitrogen monoxide. And the formation of nitrogen monoxide from its elements. The elements that make up nitrogen monoxide are nitrogen, which is N2, right? Because that is a diatomic element, plus oxygen, which is also a diatomic element. So, and that is fully balanced. This is your target equation. Now, as usual, you are given 2 reference equations and you are provided with their delta H values as well. So if you take a look at these reference equations, we have to compare them to our target. I'm just going to write our target one more time here so that it can be easily compared. Okay, so let's start with the first reference reaction. The first reference reaction contains N2, which is in our target equation, as well as O2, which is also in our target equation. Now, these two, I want to compare the coefficients as well as where they're located in the reaction. So both of them are located in the correct spot. They're both reactants in both reactions. But the difference occurs in the coefficient, right? So oxygen, the coefficient is exactly correct as the target equation. So if I'm looking based off of oxygen, it seems as if the reaction does not need any alterations, right? I don't need to change the coefficients. However, if you take a look at the N2, at the nitrogen, the reference reaction has a coefficient of 0.5, whereas the target equation has a coefficient of 1. Now, so these two, the N2 and the O2, are telling me 2 conflicting things. When you're in a situation like this, it helps for you to compare the other reference equation as well. In the other reference equations, there is an O2, right? So there is an oxygen there. However, there isn't an N2, which means that the reference reaction 1 is the only source for nitrogen. So I'm going to use that to determine what I want to do with this reference reaction 1, right? So based off of the nitrogen, I want to multiply this by 2. All right, let's take a look at our second equation. Our second reference equation contains O2, right? Just like our first one. And it also contains NO. And according to NO, I want a coefficient of 2, and I want it to be on the product side. And because that's the case, I'm going to multiply this by -2, right? Remember that the negative means that I'm reversing this reaction. So what I'm going to do is write out my reactions and see if that does get me to the target equation. So the first equation, I wanted to multiply by 2. And when I multiply this by 2, I get a coefficient of 1, right? So 0.5 times 2 will give me 1. O2 has a coefficient of 1. When I multiply that by 2, it's going to be 2O2. And then NO2 will become 2NO2 gas. Okay, I'm not going to be concerned with the delta H values, not yet. I won't do that until I figure out the correct target equation. So this is, I forgot to number them. So this is the first reference equation. Our second one, we wanted to add a coefficient of 2 as well as flip it, right? Reverse it. So there's going to be 2NO2 gas here, which produces NO gas plus 1. Oops. Got to include our coefficient, so 2NO, as well as the coefficient for O2. When you have 0.5 multiplied by 2, that'll give me 1. Okay, so when I have these two reactions, the first thing I'm going to do is try and cancel out anything that I see on both the left side and the right side. So 2NO2 gas I see on both sides. I see 2 O2 here and 1 O2 here. So if I cancel this out, this becomes 1 O2. So if I combine these reactions together, my target equation will be achieved, right? N2 plus O2 gives 2NO. That's exactly my target equation. So having decided that, I'm going to then bring in my numbers. So the first one, what I needed to do was multiply this by 2. And when I multiply 34 times 2, I get 68 kilojoules. The second one was negative 56. And I'm going to first flip the sign. So it's going to be a positive answer and times 2, right? So 112 kilojoules. And when I add those two together, I get delta H is equal to 180 kilojoules. So this is the delta H for this particular target equation. So it might take you some time, especially for example 3 and 4, for you to get to the right answer, but it helps for you to try a few things first. Always start off by comparing to the target equation, and then from there, maybe there are a few possibilities that you want to try out, and then your aim is to try and get to the target equation.